Hello, my name is Kamal Medjahre. I am full professor at the National Engineering School of Tarbes in France and member of the Production Engineering Laboratory where I do my research works. This course is entitled Prognostics and Health Management Methods, Tools and Applications. We will talk during this course about how to monitor the system, how to detect its anomalies, how to diagnose the, the, the fault causes, and how to anticipate the faults and take decisions at the right time. All this information can be used to plan maintenance interventions so that we can keep the system in an acceptable operating conditions and also to reduce maintenance costs. So to do this, we will work on how to look on the system and monitor it. So we will first work on how to identify the critical components of the system, how to also identify its degradation and failure mechanisms, and also look on which physical parameters to monitor so that we can get representative data about the system operation. Once we have done this and we have got the data, and this data can be provided by sensors or by operators, this data they can be pre-processed to be sure that they are complete and can be used reliably in the next steps. This data can then be used to do processing. In this step, we'll look on how to extract features, how to select relevant features, how sometimes to reduce the number of features, and also how to combine them or fuse them to build health indicators. We'll also, during this course, talk about health assessment of the system and also how to detect its anomalies. To do this, we will work on how to define fault thresholds. They can be alerts or alarms. We can also work on how to detect these anomalies. We'll also look in the diagnostic step on how to isolate the fault causes and also how to estimate the fault severity of the faults. Then we'll talk about fault prognostics, which consists of remaining useful life estimation or calculation, and this value of remaining useful life, it will be associated with the confidence interval, and all this information can be used to take appropriate decisions to keep the system in acceptable operating conditions and also to plan maintenance interventions. These maintenance interventions can be corrective, can be condition-based, or can be also predictive. The main purpose is, again, to keep the system in its acceptable operating conditions and also to reduce the maintenance costs. Thank you.